You, stop!
What is this? What? I don't understand. How could he solve something? How can anyone solve something like this?
So this math whiz has somehow solved an implicit differentiation equation. Now, his methods were clearly much quicker than what we are capable of, I think.
It seems that
Clearly
way.
his talent is just beyond what we are capable of. But let's see if we can break down what he's done here. So, I think what he's done here with the equation y squared equals x is the following. He's taken the derivative of both sides with respect to the variable x. So, to take the derivative of y squared, he's taken 2y times dy dx.
Right, because that's the derivative of y squared. I see.
Yes, it is. And the derivative of x, as we all know, is, in fact, 1.
Correct.
And so, after that, it looks like some sort of...
What in the world?
Oh, you know what? It's not that difficult. All he's done is divided by 2y. Because he knows that he needs to isolate dy
It
dx.
seems a little too simple. I mean, do you want to try it out? See what happens?
Yeah, let's see what that happens.
All right.
So he's divided by 2y to isolate dy dx, canceling out this 2y, leaving us with the final product.
Oh my god.
Simple yet elegant.
I don't believe it. Well, that was a very interesting problem. You know, I've been stuck on this one problem for maybe three decades or so. I mean, maybe if I use the same sorts of, the same method that was on the board earlier, maybe I can solve this problem. So the problem I've had issues with for so long has been the following. Y squared equals x minus 1 over x plus 1. You can see already how hard this is. I mean, like,
Mind-blowing.
yeah. So, but using the same steps as before, let's take the derivative of both sides. And first, the derivative of y squared, which was, in fact, on the last problem, is 2 dy over dx. And then you take the derivative of this using the quotient rule. As you can clearly see that this is a quotient. So, you take the bottom and then subtract the numerator, so then you get x plus 1 minus the quantity of x minus 1 all over the bottom squared. And, you know, this is the part I would always get stuck on, but seen from what whoever solved the last problem did, you can just divide both sides by 2y, so you get dy over dx is equal to 2 over x plus 1 quantity squared times 2y. We've done it.
Well done.
So here's our answer, and once again, the steps that we did is first we took the derivative of both sides, y squared being 2y times dy over dx. And using the quotient rule, finding the derivative of this, which is x plus 1 minus quantity x minus 1 all over x plus 1 quantity squared. And then finally, we distribute the negative, which is equal to 2, as x minus x cancels out, and 1 minus negative 1 is 2. And then divide both sides by 2y, and you get 2 over x plus 1 quantity squared times 2y.
Professor, what was that equation that we were just working on that it was just very difficult, we couldn't get it?
Well, according to my memory, I believe it's y squared plus 2y is equal to 2x plus 1.
There it is. Okay, so let's go about this. Let's start off by taking some derivatives. So we all know y squared is 2y times dy dx.
Yeah, we do all know that.
And then we have derivative of 2y is just 2 times dy dx. Is that equal to 2 plus 0?
I believe those are good first steps to take.
All pretty simple derivatives. We must observe that dy dx is a common term here on the left side of the equation. So to make things simpler, we should just factor out dy dx. Sounds good?
That's almost seems too good to be true. I would try it out.
Factoring out dy dx. So you're left with 2y plus 2 quantity. Is that equal to just 2? Now, we're almost home. We should just divide by this quantity here.
Oh my goodness.
By golly, would you look at that? Cancels. And here we can just take we can just reduce this fraction to something a little bit simpler.
By Jove, I don't believe it.
Oh, I see what you've done here. You've utilized my method.
What are you talking about, you janitor?
Oh. Let's see if you can get this other problem. It's much more difficult.
How can I get this problem? I'm a professor at MIT. What have you done with your life?
See, this problem is much more difficult. X squared plus y squared equals 25. So what we want to do first is isolate a variable on each side. So we're going to subtract x squared. So we're going to get y squared equals 25 minus x squared. Now, what we're going to do is we're going to take the derivative of both sides with respect to...
No. You know what I'm going to say that we have to do? You have to explain to me how some janitor who spends his life cleaning up peanuts and smoking with his friends and cleaning up the puke.
Shut up. So here we're going to take the derivative of both sides. So we got 2y dy over dx equals the derivative of this, which is 0 minus 2x. Okay?
Okay. See where you're going. Continue, janitor.
So now what we're going to do is we're going to divide by 2y. So we're going to get dy over dx. Because remember, this is over 2y, so this cancels out. You're going to get negative 2x over 2y. So now this is your finalized dy dx. Now let's add in a new wrinkle to the problem. What we're going to do is I'm going to ask you a wrinkle, yes.
What is this foul language you speak of?
Okay,